we can see how many integers are there between x and y. Now, in this question, we can understand that we are not being required to deliver a yes or a no for an answer. Now we need to deliver a number for an answer. How many? Let's say that the number of integers between x and y we call n. So we want to know the value of n. That is the count of integers between x and y. So statement 1 says the difference of x and y equals 3. If you just handle two numbers whose difference is 3, what results can you obtain for n? That is the count of integers between them. Okay, let's try a few values to see what happens. Say, for example, that you pick integers 5 and 2, whose difference is obviously 3. How many integers between them? Well, 4 and 3. So this represents a count of 2 numbers, 2 integers between 5 and 2. What about if the numbers were 0 and -3? 0 minus -3 equals 3. And what are the integers between them? Well, -1 and -2. Again, there is a count of 2 integers in between. It looks like the answer might be just 1, that is 2 integers between x and y. Well, what have we tried so far? We've just tried integer values for x and y. But are we restricted to only assume integer values for x and y? Well, what happens if we take, for example, number 4.1 and number 1.1? Isn't it true that the difference of these two is also 3? How many integers exist between 4.1 and 1.1? Well, you could say that there is 4, right? Then you also have 3 and you have 2. Now take a look. The count changed. It is not 2 anymore, but 3. Well, that's simply because the question doesn't define what x and y must be. It just says x and y. In the GMAT, if you are not told anything about the kind of numbers that variables represent, you assume they can represent any possible numbers, that is, real numbers in general, fractions, integers, decimals, etc. So we have tried several sets of numbers that comply with this basic affirmation. In all cases, we have only tried numbers whose difference is actually 3, but we have obtained 2 different answers. So statement 1 alone cannot be sufficient. Statement 2 says that x and y are integers. Well, between 2 any integers, there might exist an indeterminate number of integers. Say, for example, that if we pick 5 and 1, the number of integers between them would be 4, 3, 2, so totally 3. But if you take, for example, 7 and 6, the number of integers between them is none, nothing. So it's 0. So obviously, you can get any possible answer with the statement 2. It is much more open, right? But the statement 2 alone is not sufficient. Statement 1 is not sufficient. So what are we supposed to take as the next step? Well, we need to try to see if the 2 statements complement each other somehow, okay, helping each other to yield a unique answer to the question. Is that the case? Well, we might evaluate this. Consider what happens when we just evaluate values for x and y that have a difference of 3 and are both integers. We could repeat these 2 cases, right? 5 and 2, for example, 0 and -3, or any 2 other numbers, such as -1 and -4, but in all cases, we will verify the obvious. 2 integers in between, here, 2 integers in between, here, 2 integers in between. So when the 2 numbers are integers and have a difference of 3 units, it is necessary that the count of integers between them will be just 2. So now we have a unique answer to the question, which is 2, and the two statements together are therefore sufficient. What is the option that corresponds to this analysis? Take a look at option C. Both statements together are sufficient, but neither statement by itself is sufficient. It is exactly what we verified here. So that's it.